Hello everyone, my name is Zara and I'm in year 10. This is my reflection section on how far we can see into space. I love space and I love looking up at the sky, which is why I love astrophotography. I love taking pictures of the sky because I find it's amazing that I can picture something that is so far away mankind cannot even travel to it, then have it on a computer for me to look at. The photo which you can see on the screen is of a star trail which I have taken. A star trail is where you leave your camera turned on all night and it will capture how the stars have moved that night. The stars are in lines on the picture because they move around the North Star anti-clockwise. The camera will capture them moving. This is otherwise known as time-lapse photography. Firstly, this is what I can see on my drive if I just go and look up at the sky. I'm sure that most of you have looked at the sky at some point in your lives and maybe even done some astronomy. Usually you will see something like this, however the sky should not look like this. The photo on the top left is taken up on a mountain where there is no light pollution. In Lytham there is lots of light pollution from street lights, house lights and car lights, which is why our sky does not look like this every single night. This is why it can sometimes make it hard to take very good quality pictures here in Lytham, whereas on a mountain it is a lot better. On a mountain there is also a lot less atmospheric distortion from gases on Earth's surface. So, we get better quality pictures on mountains because of this as well. 100 years ago, the sky would have looked like this every single night. This is my observatory that is in my back garden. Most of the pictures on the presentation will be taken in the observatory by me. An observatory is just a building which has a telescope and other space equipment in it. During this presentation, I'm going to be starting off with moons and planets in our solar system that we have all heard of. Then, I will continue to get further away and move out of our galaxy, which is the Milky Way, leading up to the furthest thing we can see in space. We are starting off with our moon. This is a photo of the moon that I took, and the photo is stitched together from 25 pictures. As it is stitched together from 25 pictures, we call this a composite image. Composite images are very hard to take because all the pictures must have the same camera settings and lighting, meaning that light pollution or a cloud could ruin the pictures, meaning you have to set up your camera again. The moon is 384,400 kilometers away from planet Earth and can be seen with the naked eye. Now we are moving further away from Earth and to a photo of Jupiter, which is a planet in our solar system. The red spot on Jupiter is a storm, and the spot is 1.3 times bigger than the size of planet Earth. Jupiter is 900 million kilometers away from Earth, and just to put that into perspective, it would take 6 years to travel to Jupiter. As you know, the planets are in our solar system, and the solar system is in our galaxy, which is the Milky Way. The photo on the left is of a vertical Milky Way, and it is stitched together from 12 photos, making it a composite image, just like the moon one I showed earlier in my presentation. We have now moved further into deep space. This is the Andromeda Galaxy, which is 2.537 million light years away. This is the furthest thing that the naked eye can see. A light year is the distance light travels a year, while travelling at 186,000 miles per second. 1 light year is equal to 6 million miles. Light years are just a measurement of distance, and the reason why we use light years instead of kilometres is because there would just be too many zeros and the numbers will be too confusing to write in kilometres. Finally, we are in ultra deep space, and this is the last thing that amateurs can capture. Earth would just be some distant planet which we could not even see with the naked eye. Amateurs are just people with some space equipment like a telescope, and maybe even an observatory like us. Einstein's cross is 8.154 billion light years away from Earth. It is very hard to capture, and there is even a debate on whether amateurs can actually get a good enough picture of this. If you type in Einstein's cross online, it will come up with this picture, but instead of it being yellow, it will be blue. This is because the photo on the screen is taken by another amateur, but the photos where they are blue are taken by very strong high-tech telescopes. Sadly, our observatory is not strong enough to capture Einstein's cross. We are now moving from amateur viewing to professional telescopes. This is the Hubble Deep Field and is taken by the Hubble telescope, which is a telescope in space. We are now ridiculously far away from Earth. The Hubble Deep Field is between 5 to 10 billion light years away because it is so big. It contains 10,000 galaxies, each with around 100 million stars in them. Lastly, this is the furthest thing we can see in the observable universe. The universe is thought to be 93 billion light years wide. However, this is only a theory and is called the observable universe. The photo on the screen is of the GNZ11 galaxy, which is a part of the Hubble Deep Field. This galaxy was within the picture I showed on the last slide, and it is so far away that the photo shown is only really a few fragments of light. This is almost impossible to capture because it is 30.4 billion light years away. So, in conclusion, how far can we see into space? We can conclude that the furthest that the naked eye can see from Earth is the Andromeda Galaxy. The furthest that amateurs can see is Einstein's cross. Then, the furthest we can see with a high-tech telescope like Hubble is the GNZ11 galaxy. However, this may be the furthest thing we can see now, but it is possible that it will change in our lifetimes, and we will discover more of what is out there in space. Thank you for listening to my presentation.